This video is probably going to be your favorite one of all because it means the end of those circles that you have to draw over and over again in the Bohr-Rutherford diagrams. What we're going to learn in this video is how to represent atoms, elements, and also ions using something called a Lewis structure, or sometimes called an electron dot diagram. In a Lewis structure, what we really care about are the valence electrons. Remember, the valence electrons are the outermost electrons, and they're the ones that are going to participate in important chemical reactions that we're going to discuss in grade 10, 11, 12, so on and so forth. So we really only care about showing those valence electrons off. So in a Lewis dot structure, you basically ignore the nucleus and the inner electrons. You replace the nucleus and the inner electrons by the element symbol, and then simply place the valence electrons around the element symbol. So we'll do an example together. We're going to draw the Lewis dot structure for sodium. And all it really requires to do is to find out which group sodium is in. So if you look in the periodic table, sodium is in group 1. So your first step is to draw the symbol for sodium. And knowing that it's in group 1, you know there's one valence electron. So all you do is place one dot on top, and that is the Lewis dot structure for sodium. So again, it does have more than just one electron, but we don't see it here. We replace the inner electrons and the nucleus with the symbol, and we simply put the valence electron because that's the one that's going to be participating in the chemical reaction that we're going to study later on. Let's try another example over here. We have magnesium. So our first step is to draw the symbol, Mg. Magnesium is an alkaline earth metal, so we know it's in group 2. That means it has 2 valence electrons. We'll put one on top, one on the side. So usually the way I fill in the electrons is I start off by placing them singly first, so top to the right, to the bottom, to the left, then back to the top to pair, to the right to pair, to the bottom to pair, and then to the left to pair if that's required. So for example, let's look at argon. Argon is a noble gas. It's in group 18. It has 8 valence electrons. So I'm going to place them 1, 2, 3, 4, 5, 6, 7, and 8. This is the Lewis dot diagram for argon. So what we're going to do next is we're going to learn how to draw ions using Lewis dot diagrams. Similar process to the one we saw for Bohr-Rutherford diagrams, except we don't have to draw the circles over and over and over again. So we're going to practice by drawing the ion for chlorine. Remember, when nonmetals form an ion, they gain electrons and they become negative. And also their name changes. So chlorine, as a nonmetal ion, would be called chloride. So what I usually like to do before I draw the ion is I like to draw the regular structure. So I'm going to start off by drawing the regular structure in this box here for chlorine. Chlorine is in group 17. It's a halogen. That means it has 7 valence electrons. Four, 5, 6, 7. And so we look at chlorine and realize that it only needs 1 electron to complete its valence shell, so it's easier to gain 1 than to lose 7. So what we're going to do is we're going to add that 1 electron. I'm going to put it as an X, so it's apparent that I've added it, and you should do the same thing on tests or quizzes. And then you need to put the square brackets, kind of like you did with the Bohr-Rutherford diagrams, and put its charge. So since it gained 1 electron, we know it has a charge of -1. I'm just going to put negative. I could put the 1, but again, it's implied if there's no number. If it had gained 2 electrons, I would have put -2. So again, nonmetals gain electrons to become stable, to become like their noble gas. In this case, chlorine became similar to argon, right? If you look at argon, we saw that its Lewis dot diagram 8 electrons as well. And even the inner electrons of argon and chlorine would be the same amount. So chlorine, we would say, was isoelectronic to argon. From the previous presentation, we learned the term isoelectronic, meaning they have the same electronic configuration. Now we're going to take a look at how to draw an ion for a metal ion in Lewis dot structures. So remember that metals lose valence electrons rather than gain, because they have fewer than 4 valence electrons. So it's easier to lose, for example, 3 than it would be to gain 5, or lose 2 than to gain 6, or lose 1 than to gain 7. So I'm just going to start off by drawing the regular, or the neutral magnesium. It's in group 2, has 2 valence electrons. And you just take a look at what it needs to do. How many electrons does it have to lose to complete a valence shell? Well, it needs to lose 2. So what you do is you simply erase the electrons that you drew for a metal, and you put the square brackets around the symbol for the element, and you put the charge. How many electrons did you erase? Well, you erased 2, so positive 2. This doesn't mean the magnesium doesn't have electrons anymore. It just means that it lost its valence electrons. It still has electrons underneath. Just as a point of reference, let's go back and take a look at how this would look like for the Bohr-Rutherford diagram. Magnesium, we know, has 12 protons and 12 neutrons. And it also had 12 electrons. So that's the regular magnesium. And when I say regular, I should really be saying neutral. So 8 on the second shell here. And then 2 on the last. Now, if we were to form the ion, we know we'd have to get rid of these 2 on the last. So I'm just going to take my eraser here. Get rid of that last shell. Draw my bracket to show that I've made an ion. And that would be +2. So this Mg over here really represents, the Mg in the Lewis dot diagram really represents what's left over afterwards. But we don't represent those in the Lewis dot diagram. We only care about valence electrons. So magnesium doesn't have any valence electrons left on that last shell that it initially had. So we just leave that symbol kind of naked, and then we just put the charge. Okay. If it was something that lost 3 electrons, you would have left it naked and then put the charge at +3. And just again remember that when metals form ions, their name doesn't change. It's just, this is magnesium. Okay, we can say the magnesium ion if we want to, but it's just magnesium. But non-metals, their name does change, so this would be chloride, not chlorine. So chloride, and then magnesium. So you should be able to draw Lewis dot diagrams for any neutral element and any ion that forms. You should repractice the ones that we did in this lesson: magnesium, argon, magnesium ion, and the chloride ion. And then you have a few more practice problems to do over here. You'll notice over here we have the oxygen ion that you have to draw and the phosphorus ion you have to draw. Since these are non-metals, you know their names will change. So I want you to find out what their names would be once they're in the form of the ion. Again, metal names don't change for ions, but non-metals do. So try to find out what we call phosphorus once it becomes an ion, and oxygen once it becomes an ion. This is your favorite periodic table, where you have to draw all those Bohr-Rutherford diagrams for the first 20 elements. But in this case, you might like this one a bit more because you're only drawing the Lewis dot structures for the first 20 elements. So for example, your hydrogen would look something like this. Your calcium would look something like this, as opposed to having all those circles because it's in the fourth period. The circles and the inner electrons were replaced by the symbol for calcium, and we're just really focusing on those valence electrons. In this periodic table here, you have to draw the Lewis dot diagrams for the ions as opposed to the neutral atoms. So you can compare your neutral atom periodic table to the ion periodic table. And then you can answer these analysis questions over here. Pay attention to the ones with the question mark, because we don't know if they form ions or not. Think about why there's a question mark there. Why would I put a question mark for group 18 elements and group 14 elements? Think back to the previous lessons.